Okay, I propose we will start the session, Gilles.
Okay.
So for today, we will dive into the analytics. So all the previous sessions were more on general issues related to soil contamination, plant uptake, modeling, remediation techniques yesterday. But today we will go in the laboratory, and from now on, all the presentations will be based on which methods you will also learn and practice when you come to Belgium. So all the methods you will see from now on will also be learned in practice in the labs in Belgium. So this morning, we have gathered all the methods more or less related to nutrients in soil and how to determine it. So it will be more related to fertility parameters, if you could say so. In the afternoon, it will be more on cation exchange capacity, also soil available micronutrients, and last but not least, also the determination of the particle size. But that's for the afternoon. So we have quite a full agenda for today. I propose we will start and then take a break once in a while for answering questions. And please, Gilles, also consider taking a break sometimes if you think it's time to receive questions. So the floor is yours, and good luck.
Thank you. I will share my screen. Okay, so do you see my presentation?
Yeah, it's all fine now, Gilles.
Okay, so good morning, everyone. This first session will be about a synthesis of the what was planned A3, A4, A5, A10. I gathered these as under the title of Soil Major Nutrient Analysis, because as we will see, we will speak about mineral nitrogen and about the forms that are called mobile P, mobile K, mobile S. In the literature, you find sometimes the kind of qualifiers such as available, assimilable, exchangeable, and so on. So there are many words, but I think we can retain at this moment the mobile, which is significant as an image. I will begin with first consideration about the preparation and of the samples and what is all behind the whole process of making analysis. There is a procedure SOP from the FAO about sample preparation, and it is valuable for every kind of soil analysis. If you look at the general scheme, you have the soil, and the first step is dry if necessary. And of course, there are parameters which can be done on dried soils and others that should not. Usually, when we are making measurements of the mineral nitrogen, we work on a fresh soil because when you dry the soil, you modify the content, and it may not be representative of the reality of the field. It might be okay if you want to make samples, control samples with defined levels of nitrate, for example, or ammonium. But if you want to have a good representation of what is really in the soil at the moment of you do, or at the moment where you do your sampling, drying is not a good option. So some analysis should be made on dry soils and others should be made on fresh soil. Then you have an operation of disaggregation. At first, I go back to the drying. There are options too, which are leaving it dry at the air temperature or inside air temperature, or the option of rising the temperature in an oven. And here again, according to the parameters that you are going to analyze, the temperature, the maximum temperature may be a limit. Usually we try not to go over 40 degrees. So sometimes it can take time to have the soil dried. If you have a really wet soil and you want to dry it, sometimes it can take a few days or before they are ready to the next step. And you should be aware of that. And if soils are very clayey, they become very hard to disaggregate after. And so you should go often see the evolution of the humidity of the soils in order to begin the disaggregation. So the disaggregation is the physical breakdown of the aggregates, and you have to sieve to 2 millimeters because most of our procedure with the soils are based on the fine earth, which is the soil under 2 millimeters. All the parts that are above 2 millimeters are considered as stones. And the difficulty is to be gentle with the aggregate. So you disaggregate the aggregate, but you don't break the stones. And sometimes if you have a chalk or a very smooth stones, it might be somewhat difficult. We use mortar and pillow. I don't remember the exact English name. You have the material on the photos. We use two different kind of furniture according to the need to have a neutral matrix according to what you measure. For example, if you want to measure the trace elements in the soil, the porcelain might be liberating some trace metals in the or other elements in the soil. So we prefer to use this in agate material. And we work under aspirating atmosphere in order to prevent the dispersal of the dust in the lab. So we try to disaggregate as smoothly as possible, and what cannot be crushed, we will separate it, and sometimes we wait to have the relative quantity of above 2 millimeters and below 2 millimeters. Depends on your study. Then you have possibly subsampling if you want to for example, to keep one part for the storage and one part for the analysis. And you must follow a strict procedure in order to be sure that the two parts are the same, are as homogeneous as possible. So there are some easy procedures, but a bit long. You mix them, you separate, you remix, you re-separate, and so on. We also have an apparatus that is able to part a sample into 8 different components. I don't have the photos of that, but the material exists. Another reason why you should make a subsample is that some of the properties are measured on fine soil, which will be less than 500 microns or less than 200 microns, according to what you want to measure. And that's typically the analysis of total content. When you want to make total organic carbon, total nitrogen, total elements, mineral elements, you try to have a size of the grain as small as possible, and you will treat the subsample with the mortar. And the idea here is that there is no refusal of material. When you take your subsample, everything must go through the new sieve. And so usually we use this material in agate. And so it might be tricky when you have sandy soils to make them go under 200 micron. So this is the general sample preparation, but behind that we need, as we are part of a structure that organize a proficiency test, and we also participate as a participant, not organizers of other proficiency tests. We need to have a quality control, a data, a system of management of the quality in the lab, and it begins with the identification and reporting of the samples. Here you have an example of our book of samples. So we began this book in 1989, and now we are in 2024, and we have more than 30,000 samples that have been entered. Here is an example last year. And you must give information about the people who is responsible of the study, the kind of samples, if they are contaminated or not contaminated, so the date of the sample, and then you have a unique ID for every sample. GC for glycolinate. I am often the responsible of the samples, even if I didn't collect it. And this is an increasing number. So that was the samples number 28,060 last year. So we have more than 30,000 samples now in the books. We try to make it digital, but for the quality procedure, we need to keep handwritten books of all the samples. And so we also try to keep samples in order to go back to the samples if we need to redo an analysis, or if we have new topics, we can get value these archive of soil science. So we don't keep everything. We try, but often the room is not enough, and we have to make choice and have a procedure of elimination of the samples that we will not keep. So we have a good archive. It's a bit messy sometimes when we have to make room free. So as I was telling, we needed to organize all the quality, the system of management of the quality in the lab, and there is a norm which is ISO 17043 for the organization of proficiency testing, and we are trying to organize all the quality of our lab. Not only for that procedure of proficiency testing, but for every kind of analysis that will be made in the lab. If it's for the students, the master students, that they need to make some lectures, they are also obliged to respect these procedures that are put in place. It begins with it's a lot of procedures and instructions and so on. It begins with the identification for every room of the list of persons that are allowed to go into that room. Also, the list of activities that are compatible with the space, and if someone is making one kind of, for example, plant sample grinding, another one should not use the same space for soil grinding, for example. Every material that is in the lab, even a balance or the kind of more sophisticated, such as ICP and so on. Every material is referenced as a number of identification, and close to it there are 3 books with the operating instructions, notebook to write if you have some problems, to write if you make calibration, and so on. And yeah, every balance should be calibrated, and in the procedure of data quality, you calibrate it with the control weight that you put on it, but you must prove that you control the weight often. So everything is should be under control, and every operation should be documented in the book of analysis. So it means that management of the quality in the lab is a big collection of documents and procedures to follow. And sometimes it may appear a bit difficult, especially for PhD students that like a little bit of liberty, and they don't like too many constraints. That's something we find in the within our experience, and but yeah, at the end they have a quality insurance about the work that they have done, and everyone is happy in the lab if you respect them. So it was the preliminary points about the analysis in the lab. So for today, there are some SOP that were available from the FAO, such as the sample preparation. I already told it. There is also a SOP about OLSEN-P, which is an evaluation of the available phosphorus based on the extraction with the sodium bicarbonate. In the list of subs from Ukraine, there were some for mineral nitrogen with extraction with the K2 sulfate potassium. In Belgium, for mineral nitrogen, we have a different procedure which follows an ISO norm, and it's extraction with the KCl and the colorimetry, and we use that one. There is also one procedure for mobile P and K. So they use the same extractant for in Ukraine for mobile P and K, and it's carbonate ammonium. And also another one with the mobile sulfur, with the precipitation of the sulfate by barium chloride. In Belgium, we have a procedure for a method, which is Lacanen-Hervieux or Courtney, depends on the reference. But the most recent is Lacanen-Hervieux for P and K. It uses ammonium acetate and EDTA at a pH fixed at 4.65. As a general rule, when there was SOP from FAO, we used it. When we had, otherwise we used our methods, or for example, mobile sulfur is something that we did not make the measurement yet in the lab. we are making some experiments with the ammonium acetate, but yeah, in this case we used we followed the SOP from the Ukraine. We just changed the measurement. So the extraction was from the Ukrainian method, and the measurement was from our equipment. So we will begin with the mineral nitrogen. So when we speak about mineral nitrogen, so that's a slide I already showed in the general overview about soil fertility. Mineral nitrogen is mainly composed in the soils of ammonium on one side and nitrate on the other side. In our soil, nitrate is the dominant form of nitrogen that you will find in the crop soil. Because when you put ammonium, there is either uptake from by the plant or the nitrification processes by the microorganism, and the ammonium is transformed into nitrate. So these are the two major forms that we measure, but usually as a fertility and environmental issues, the main form that we follow in Belgium is the nitrate in the soil. But there are other forms of nitrogen in the soils, which are the organic nitrogen with the microbes and the organic matter, the labile and stable forms of organic matter. To give you ideas about the ranges of magnitude of the content of nitrogen in the soil, usually the mineral nitrogen is measured in milligram per kilogram of soil, and you usually found most of the concentration between 0 and 20 milligram per kilo nitrate or ammonium. And if you look at the total nitrogen, usually the mean level is 0.1 in crop soil is 0.1%. So it means 1,000 milligrams per kilo. So it's 50 times more than the mineral nitrogen. So you should be aware that mineral nitrogen is only a small part of the total nitrogen. And if you want to make assessment about the potential of nitrogen furniture to the plant, you should take into account the organic nitrogen too. It's an important source of element for the plant. So regarding the measurement, so there is a national standard of Ukraine, which is DSTU 4729 in 2007. And the general principle is that it is based on the colorimetry. So general principle is that for colorimetry, you have a mix of sample and extraction solution. So it's sulfate potassium in Ukrainian SOP. It's in our method, it's a chloride potassium. You have a phase of agitation of the samples. It depends, the time depends on the methods or the reference of the labs. And then you might have centrifugation or not centrifugation, but usually you filter the extraction, the mix. You filter it on a paper filter. You have the extraction solution. And for colorimetry, you will add some material, some products in order to change the color. And you will work at a given wavelength according to the methods. The idea is to have known standards with the different gradient of here of a green color. You will make a calibration curves or calibration line, and then you hope that your sample is falls within the range of your standards. Otherwise, you might have to dilute the samples or to extend the curve and so on. So that's the main idea. This is read by absorbance at a given wavelength. We look at the absorbance by the color, and we make a line, and then we pass the samples and have a reading and transformation of an absorbance into a concentration. So I will first begin with the general scope of the Ukrainian, and then I will look at what we changed. So for the DSTU 4729 from Ukraine, it is referenced as procedures for measuring the weight fraction of nitrate and ammonium nitrogen. So weight is in percentage or a milligram per kilo of soil and so on, in both natural and disturbed soil types. So you could have a broad range of soils that are on that can be measured. So it is used to monitor soil fertility, certification of agricultural land, or the survey, prospecting, research. But it should not be applied when you have a big organic matter content, here more than 25%. So I don't know if there are many soil types in Ukraine with these levels of organic matter in the Chernozems and so on, but in Belgium we don't have these levels except in forest soils. So the principle here was spectrophotometric measurement of the nitrate on the one side. The idea is that the nitrate is able to absorb ultraviolet rays at a wavelength of between 220 or 240 nanometers. And so you will make, the idea is that you make a reaction between the nitrate and phenol disulfonic acid, and the component will make a trinitrophenol product, and in alkaline medium, this trinitrophenol make a new product which is yellow colored. It's ammonium trinitrophenolate. So it gives a yellow color, and the intensity of the color is proportional to the nitrogen content. So then you make these coloration, and then after you put the samples into a photometer. For the ammonium nitrogen, it's another reaction that you will use. You will use a reagent which is called the Nessler reagent. And then you will have also a product which is colored in yellow. So it's also a kind of photometry. So so it means that you have two operations of a measurement. You need to measure both. You cannot make one single measurement of nitrogen and ammonium. And regarding the extraction, it's with 1% potassium sulfate solution. So what changes in the ISO method that we used? It's the ISO is automated method to measure nitrate, nitrite, and ammonium ions in soil extract with 1 molar case chloride potassium. It also applies to all soils, according you made them homogeneous, of course. And so in this method, it's you have this the extraction of the solution, and then you have a measurement by automated spectrophotometric methods, which can be segmented or continuous. So it means that in the segmented flux, you send the flux of nitrate at given frequency, and in continuous, it's as the word is significant, it's continuously going into the system. So in our procedure, there is a long list of reagents. Here you have 3 different reagents to make the coloration. You see it's yellow coloration for ammonium. And you also need some reagents to push. It's the buffer solution, which will push the bubbles of yellow colored material solution in the apparatus. The same for nitrate. We have also other products, and for the coloration development on one side, and for the feeding of the apparatus on the other sides. So you have a list of products for color development and another list of products for the buffer solution. Here is photos of the device that we have. We recently bought this one. There are many others, of course. Here we have so it's a SEAL auto analyzer AA100. In this one, we have 2 lines of analysis. So the samples are taken up here. They go through tubes into the machine. And we have 2 lines of analysis. This one here is for the nitrate, and the other one here is for the ammonium. And so it's automated, and the system is making by himself the extraction of the samples, the color development. So the time of moving is calculated in order that when the solution goes to the reader in the machine, it has well developed the color that it should have developed. That's a point maybe I should have added before. When you have a color development according to the methods, sometimes you need the color might be immediate, and at other time it needs sometimes to develop well. It may be 40 minutes, 45 minutes, 1 hour. And also there is a time lasting of this color. Sometimes after 3 hours, you should not try to read the sample anymore. So 2 lines of measurement. What is important here? It's in the procedure, and of course it's the same for a lot of procedures of soil analysis. You should prevent any soil warming. Here it's because you will work with fresh soil, so you will try to take all the precautions in order that the soil is still representative of the moment at which you sampled it. If you leave it at 40 degrees in the car during one day, there will be some kind of microbiological activities with maybe more nitrate, less nitrate, more ammonium, and so on. And so the soil will not be representative anymore. You will be able to measure something, but you will not be able to interpret it correctly. So in the procedure, if samples are to be analyzed within 3 days, you can store them at 4 degrees. If not, you should freeze them at -20 degrees centigrade. So that's the procedure. What we do here is that we do the extractions within 2 days. We keep them at 4 degrees. We do the extraction within 2 days, and we freeze the extracts if we cannot measure them. So we don't freeze the soil samples, we freeze the extraction solutions. We made tests and it is good. And then after you unfreeze when you are ready to make the analysis, you unfreeze at ambient temperature if you are able to make the extraction. So that's when you have the soils within 4 hours. If you so when you want to make the extraction, first you must homogenize the sample, the soil sample, by mixing and sieving. In the procedure, it's at less than 5 millimeter. We use sieves of 8 millimeters, and yeah, we made some tests, and it does not fundamentally change the things. And then, so we sieve everything at 8 millimeters, and we take a subsample in order to measure the soil humidity. Because at the end, we correct the results relative to dry soil. So we must know the humidity of the soil. So that's the kind of big sieves that we have made. And when we are making campaigns of analysis for the measurement of the nitrate in the soils at the end of autumn, in order to fix the legislations standards every year. And so we need to make a lot of samples in a few times, and we have these kind of grades that are pretty good for the soils. Sometimes it's difficult with the clay soils when they are humid, but for most soils it's good. Then the soil is extracted with a solution of molar KCl under a mass ratio of 1:5 at temperature controlled temperature. It's the lab temperature, 20 degrees plus or minus 2 degrees. And what the ratio 1:5 in practice, we take 40 grams in 200 millimeters, or sometimes it's 30 grams in 150 milliliters of KCl. The agitation time is 1 hour. Then you should centrifuge. In the norm, they say that you take a part of the 200 milliliters, you take 60 millimeters, and you centrifuge at 3000 G during 10 minutes. They recommend in the norm not to filtrate on a paper filter, because there might be interference with the ammonium content. Our bet, we don't centrifuge, we still use the filtration on paper. And we use after the solution for both nitrogen and ammonium, but usually we measure ammonium, nitrate, sorry. In order to evaluate if there are problems, we use blanks, we use control samples and so on in order to detect if we could have problems with the contaminations of nitrate or ammonium. So regarding the nitrate and also the nitrite measurement, the idea is that the nitrate ions are reduced in cadmium copper column. So it's we before the last year, we were using cadmium column that we were doing by ourselves. So it looks like that. You have a vessel with at the bottom of the vessel a mixture of cadmium containing material, and you put your extraction solutions there. It goes through the column cadmium, and the nitrate is reduced into nitrite. And the nitrite is the elements that you measure at the colorimetry. So at the beginning it was okay. Then we faced some problems. We always had to regenerate the cadmium, and when we made our prophecy testing, we had some bad results, and so we decided to change. And now we have automatic analyzer, and this is one of the possible reducing device that you can find. So that's the one we used. You can also have a device with a cadmium column containing that one. Maybe we will do that because we also face problems with the stability over time of that. There was a question, no? No? Okay. So the nitrate are reduced in nitrite, and the idea of the analysis is that nitrite plus sulfenamide plus that product form diazoic compounds that absorb at wavelength of 543 nanometers, and it gives a beautifully purple color here. You see in the device. So the absorbance at 543. And regarding the ammonium measurement, it's another other transformation. So we have a salicylate sodic salicylate transformed into indophenol compound in the presence of ammonium and Na-dichloroisocyanurate, and it turns blue-green under alkaline conditions, and it absorbs at 660 nanometers of wavelength. And so we have, of course, we make standards. These are the level. It's just here to give you the level of concentration we have in our standards. So for ammonium, goes from 0 to 3 milligram of nitrogen in solution, and for nitrate it's a bit larger. It's until 4 milligram nitrogen per liter. So with these standards, we can usually measure what we find in the soil extracts. Regarding measurement, as it is automated, we have a device to. We have a device to take up automatically the solution in the small tubes. And after there is a computer that follows the evolution of the samples, and we have a graph that allows us to have a look at the progress of the analysis. So one is for the nitrate and one is for the ammonium. So that one is the standards, I guess, that are passing, and then after you have the sample, and if they are in the between the maximum and the minimum, it should be okay. And so we have directly the results into nitrate or ammonium and not in absorbance. But we could find the information back if needed. And then at the end, you have a concentration in milligram per liter, and you need to make calculation to milligram per kilo, or sometimes in kilo per hectares, and so you will need after other transformation coefficient. But yeah, to express the oxide nitrogen nitrate nitrogen, we have the extract minus the blank multiplied by coefficient, which take into account the volume that you took, the mass of the samples, and the water content. So it's the same principle for ammonium nitrogen. If you want to express it into kilo per hectares, you need to know the density of the soils and the volume that you considered. So we made the measurement, and we also had measurements that were made in Ukraine. So I put here the comparison of what we measured and what was measured in Ukrainian. Given the fact that we worked on dried soils, and so we don't know exactly if the Ukrainian did the same, but if we compare, so this is Ukrainian in the abscissa and our results in the y-axis. You can see this is the 1-1 line. So it means that in a perfect world, all the samples, all the results should be along this line. It should show that the methods are give the same results. Here, if you look, we see that there are some differences. So some of the samples are along the line, but you can also find some differences here. We measured for some tenths of samples. We measured higher levels than what was measured in Ukrainian soils. And here, for these two samples, for example, it's the Ukrainian that measure higher level than what we measured. And regarding the ammonium, see again that you find these two levels of differentiation, and also for some of the high value in Ukraine, we also had higher values in our cells. So the correlations are not so good, but you always should know that when you give samples to different labs, you have discrepancies. You don't have exactly the same. Even in the same lab, you have analytical variability, and the idea is to acknowledge this variability, or you accept it, or you don't accept, and you try to reduce it as much as possible. In this case, we should not be we should not worry too much, as it was made by different methods, and maybe the samples were not exactly the same. And we also know that mineral nitrogen is more should be more interesting in under fresh soil. Regarding the quality of the analysis, we participate to a proficiency test that is organized by one of our partner. We do proficiency tests for soil parameters, and they do it for the mineral nitrogen. We are the lab 2, so I can show you this graph. So usually there are different labs that are working. So that's first labo, labo 2, 3, 4, and so on. And the color are different samples. So they are repeated. So we have 6 samples repeated twice. And the idea is to look at the performance of every laboratory. Here, the samples are all control samples. And so they can be used sometimes. And you see that some labs are, so this is the variation with the the variation to the mean. And if you are under, it means that you are globally giving results that are under the reference value. If you are over this line, you give a higher value than what is expected. And so this is the limits that are fixed here. -2 and -3 are considered as if you are within this area, it's okay. If you are over the orange line, you should make an effort to see what happens. And if you are over the red line, so that's that score. If you are over the red line, you need to take an action in order to correct what happens. And so, yeah, here with this graph, as you can see that we control our nitrate performance, and it's correct. It's better now that we have this automated sampling, automated analyzer.
Yeah.
Okay, I will make a first stop here.
Okay, thank you, Gilles. I asked some question in the group because we didn't know how experienced people are with the spectrophotometrics, but it seems that at least some people have indeed already a lot of experience with extraction and spectrophotometric methods, which is of course good. I have noted some questions on the last slide that you presented. Can you briefly explain what the Z-score means?
Yeah, Z-score is a calculation of you take your sample minus the mean of the results divided by the standard deviation. And so it gives you an information of how much you are far from the mean, expressed in terms of the quantity of the standard deviation. So if you have a Z-score of 2, it means that you are 2 times the standard deviation away from the expected value. If you are 3, so we tolerate, we accept that the variation of your results compared to the mean, and the mean can be the mean of all the lab. If you don't really know, you don't have a target value. It can be the mean of every lab altogether, or it can be a target value that is fixed when you have control samples, such as when we work with the BPA, for example, in France. They give you the values that you should have, and also the interval of tolerance. And so here we use the Z-score. So if it's -2 and +2, means that you have a variation of 2 times the standard deviation. If you go larger than this Z-score, you should begin to have a look at your results. If you look at the Labo 11, he clearly has problems with the samples. And after 3, over 3 or -3, we consider that there is a problem that needs to be fixed.
Yeah. Okay, thank you for the explanation. Another question, you showed some comparison between the extraction on the more or less 40 soil samples, I think, measured with what you call the Belgian method, and on the other one, the Ukrainian. Like you correctly said, indeed, the samples have been shipped to Belgium. We don't know about temperature, and mineral nitrogen is very sensitive to possible changes. So indeed, we have to be very careful.
Yeah,
but
sure.
on the other hand, and more in general, Gilles, what is your experience? Because I think mainly it comes down to what kind of extraction method you use. And of course, there are different extraction methods possible, as you said earlier, FAO, ISO, Ukrainian. Is it possible to compare or to derive what you could say like transfer functions to recalculate the concentration in one extract to the other ones, or what is your experience with this?
Oh, I think it depends really on the parameter that you follow. I think I will show later on for other parameters, but for some you have extractants that are very similar in behavior, or what they target as elements. And what, for example, is important is to have a kind of salt concentration, and if the anions and the cations are different, it might be not a problem for some of the elements, but it might be for other elements. So I think in some situations you can have transfer function of one to another, but I think it also depends on the context. Here, I'm not sure you could do the same transformation equations for Ukrainian soils, for example, and for our soils. If you take soils that are more clayey, more rich in organic matter, and so on, then our soils develop humus, and so it will really depend on the nature of soils. But in specific context, I think that you could try to, and for some of the elements, you could try to have a kind of a pedo transfer functions here.
Okay, thank you. I think this is something interesting as well to consider later on, because at the European level, they are trying to get maps of Europe, and one of the issues also within FAO, if you see at the global map. So that's a point of attention, and also these transfer functions get a lot of attention, because indeed in some nations different methods are being used, but to convert it to something else, it's difficult. But okay, it's good to mention. And then maybe a last question, maybe that's on the side, Gilles, but the timing of sampling, you mentioned something. When are the timing you typically would go to analyze mineral nitrogen on the soil? And I mean, depending on the season, I mean in that.
Yeah. We made some. We are working in project where we fix the levels that are normal for crop soil and grassland in Wallonia. So we every year we fix the range that are considered as normal and the range that are considered as too high by making two periods of analysis. One is in 15 October to 1st November, and the other one is 1st December to 15 December, because all the control that is made in the farms is done during the October and December. So we try to fix this season, and this is the season when you estimate the quantity of nitrogen that is in the soil, and that will not be taken by the plant during the winter because there is no plant. And so it is potentially it could go to the aquifer. It could migrate to the aquifer. So it's kind of what is the quantity of mineral nitrogen that is in the soils and that is potentially going to the aquifers. Of course, it's a bit shortcut because we encourage the soil occupation to have plants in the winter, cover crops and so on. So
okay.
So that's one, and then after there is another period which is made at the end of the winter and beginning of the spring, because that's the amount of nitrogen that is still in the soil, and it will orientate the fertilization. So that's the time where you do it before the the farmers make their fertilization plan, we do that. After, if you make measurements of mineral nitrogen in the soils, it's more to monitor the evolution of nitrogen, but it's more for a research project than really applied fertilization plan.
Okay, that's clear regarding the timing. I would propose to have a 5-minute break, Gilles, so everybody can get some coffee or go to the restroom if needed, and then we will start within 5 minutes back with the next one.
Okay.
All right. I think we had a short break. We can continue. Maybe it's just another question, Gilles.
Yep.
When the training will be done in your lab. Will this be on this automated spectrophotometric determination, or what was the plan?
Yeah, yeah.
Okay, okay. It's just good to know. Okay, thank you. So please go on with the next part of your presentation.
Okay. So after nitrogen, we go to phosphorus, and we follow the SOP from the FAO about the Olsen P. So when we speak about phosphorus, what we aim to measure is the quantity of phosphorus that can be taken by the plant. And so if you remember this image from the other PowerPoint here, the total phosphorus in the soil is about 1 to 3 tons per hectare. The plant need is 20 to 60 kilos of phosphorus per hectare per year. And the phosphorus in solution is a few kilograms per hectares. And so the plant is obliged to take the phosphorus that is in soil solution. And this soil solution must be fed by the reserves of phosphorus in the soil. And the reserve of phosphorus are either organic or inorganic phosphorus. The proportion of the two, organic or inorganic, is very variable. Sometimes you can have 70% of inorganic and 30% of organic, and other times you will have the reverse balance. It's 70% of organic and 30% of inorganic. Of course, it depends on the context. If you have soils that have very rich in organic matter, they will have high content of organic phosphorus. From the organic phosphorus, it's sometimes difficult to forms that are difficult to mobilize. So you need to have the transformation by microorganism, of course. And so there is a part that is active and a part that is more stabilized. Regarding the reserves of inorganic phosphorus, it may also be tricky to mobilize them. There are a lot of experience in the world that say that when you put phosphorus as fertilizer in the soils, significant proportion of this phosphorus is sorbed by the soil and is difficultly, hardly available for the plant. And so there are processes of sorption, desorption, and precipitation dissolutions that are to be taken into account. And when you want to have an assessment of the quantity that is available for the plant, you can either measure the dissolved, but it will just be the instantaneously mobilizable by the plant. If you want to have the reserve that can be on the duration of the whole growth of the plant, if you want to know that, you have to have reactive agent that goes and take a part of these sorbed and precipitated phosphorus. So I was promoter of a PhD student some years ago, which was working on the issue of phosphorus mobilization in the soil. And she made a review about the tools to evaluate the status of soil phosphorus. And there are tools for modelization, but also tools for characterization. And tools for characterization, you have different kinds. You can have chemical extractions, that will be our topic today, anion exchange resins, biological extractions, and also isotopes. A lot of work have been done in different countries about isotopes. the people who work on isotopes consider that's the only way to exactly know what's the fate of the phosphorus and where are the sources in the soils. So here we work with chemical extraction, and you can have different kind of extraction. You can have single extraction of phosphorus content, and you find water extraction, but you also find Olsen extraction. You can have sequential extractions. So it means that you, for the same soil, you put different reactant that are progressively more and more aggressive. And so there exists some protocols. And also another one that we worked on is the degree of phosphorus saturation. The idea is that in our context, the phosphorus can be sorbed on oxides of iron and aluminium, and we try to dissolve them and measure the phosphorus that is linked to their sorption. But today we will speak about the single extraction of phosphorus content. The idea is the same as for the protocol. The idea is the same as for the nitrogen, is that you will work on a colorimetric assessment. So in the standard of Ukraine, it's the determination with the same extractant of both phosphorus and potassium. But we followed Olsen method from the SOP of the FAO. So the principle of the two, it might be interesting to compare, is that in the Ukrainian methods, you use ammonium carbonate solution, at ratio of 1:20, and then you made a development of color in blue. There are two big colors for the phosphorus. One is in blue and one is in yellow. And so here it's a blue phosphate molybdic complex. And then you will have to use a spectrophotometer for the phosphorus and a flame photometer for the potassium. Here in the Olsen P, the idea is to have an extraction with the sodium bicarbonate, 0.5 molar, at a constant pH of 8.5. So the idea is that when you put sodium bicarbonate, you put, of course, HCO3, and the anions that you put into the system will control the activity of calcium, aluminium, and iron, which have big interference with the phosphorus. Phosphorus can bind strongly to them. So the idea is to put the bicarbonate to precipitate calcium as the carbonate, the aluminium and the iron as hydroxides, and the phosphorus stays in the solution. So the procedure was developed at the beginning for calcareous soils, alkaline soils, neutral and slightly acidic soils, which contain calcium phosphate. But often you will find publication in the literature that use Olsen P in other contexts with more acidic soils. And it is, I think, the most widely used indicator of available phosphorus. It's the Olsen. And we were speaking about transfer or function from one method to another one. Here in the we had a former PhD students that a long time ago did a comparison of the extractant. And he compared 4 methods, and he compared them with the uptake of a plant. And so he compared the Olsen method, another one which is called Schuller or lactate, acetate lactate. Also, you find it in the literature. It's the former method that was used in southern Belgium. So it's a combination of calcium acetate and calcium lactate. He used cyst, which is an extraction in water, and the cottony method, which is the method that we use now in southern Belgium, because we try to develop a single method for all the parameters that we can. And so we use the same for phosphorus, for potassium, for calcium, magnesium, etc. So he made comparison, and as you can see, he had very significant correlations between the phosphorus extracted. The best one was between Sissing and Cottony, but Olsen was significantly, very highly significantly correlated with all the other ones. So that was for oh, sorry, that was for soils from representative of all the agricultural regions of southern Belgium. So the principle of measurement, it's based on a spectroscopic method linked to the color development. It's also a blue correlation with the molybdenum. So the idea is that in an acid environment, so you have to put to be sure that it is acid, you put some acid in the extractant. You have molybdenate solutions will react with the phosphate in order to make phosphomolybdenate complex, which will be reduced by ascorbic acid and other reducing agents in the presence of potassium antimony tartrate. So you see that you need some different kinds of product and reagents in order to make the color development. And the intensity of the blue varies with the phosphorus concentration, of course. The wavelength to make the measurement is 882 nanometer. So I took copies from the method, and this is general for all the methods that are used, is that the chemicals should be of analytical grade. So you see that there is the deionized water. Extracting solution is with sodium bicarbonate. You use sulfuric acid to be sure that you will acidify and make the coloration processes. So you have a different kind of products. Yeah, I don't make advertising for any mark, but yeah, we have to use products that are higher grade. So you use your extracting solution. You control the pH of the solution by adding NaOH eventually. Yeah, in order to be at a point at pH 8.5. Then you will use all these reagents that are graded. So you use sulfuric acid. You use different kind of products in order to make all the reagent. So the mixed reagent will you will add water, sulfuric acid, ammonium molybdenate solution, ascorbic acid solution, and then potassium antimony tartrate solution. Get that one. So according to the products, sometimes you can use a balance with 2 digits. Sometimes you need 3 digits, and sometimes you will need 4 digits at the balance according to the precision that you need to in order to make your solutions and your extractions. You see here it's 2 digits, and at the end you have a reagent mix that and then of course you do calibration standards and the idea is to put your you take your mixed reagent, you put it on vibrating in order to make the development of the color. And at the end, you should have these blue. So I guess it is the standards from 0 to the maximum of blue coloration in the standard making. You always have a fear because it takes some time to develop the color, and you are making in parallel your standards and your samples, and it's always you're always a bit afraid that your samples looks with the blue, which is darker than your maximum standard. So it means that you should re-begin. Okay, so you will read if you need the whole procedure, but the idea is that you take some samples, you add some charcoal, because you can have interference in the color development of what you are extracting with the bicarbonate solution. You could have dissolved organic matter, for example, and so on, that might interfere in the color. So we usually put 1 teaspoon of charcoal, activated charcoal, in order to reduce these interferences. Sometimes it's not enough, and we have to begin again. Especially with the very organic soils, it might be a problem. So after its agitation on a vibrating table, don't remember exactly the time, and then we filtrate on a standard filter paper. Then we take 3 milliliters of the blanks, the sample extract. We add the 3 milliliters of mixed reagent, and we allow the solution to stand for at least 1 hour for the blue color. So you see here, blue color needs 1 hour to develop at maximum. We use this nanocolor spectrometer. We have 2, but one is very, very old, and you need to pray before it works. And that one is a bit more new. And so we don't have automated sampler taking, so we need to work by hand. And at the end, again, you have a measurement of the either of the absorbance, and you transform into phosphate, or read directly in phosphate. And again, you have the formula that takes into into account the measurement, the blanco, and the volume that you took into consideration, the mass of soils, the dilution factor, because you need to take a part of your extract and to make the development of a coloration, and sometimes you need to dilute it. and of course the moisture factor that you need to take into account also. The SOP also gives information about quality insurance, quality control, and so it's advice to participate in a proficiency test once a year, to make, of course, corrections or corrective actions when it's needed, and to perform replicate analysis of certified reference material. That's the general idea, and this is something that you can generalize to any SOP, of course. Also, you can evaluate the precision of the test. As I said before, you always have variability in your results. You can do twice, 3 times, 10 times the same analysis. You will have 10 different results. That's normal. It's linked to the variability in the conditions of the measurements, and also variability of the soil samples. But you have to know how much variability you have, and here you will calculate variability in relative percent as the standard deviation of the replicate results divided by the mean. Usually, in our results, we accept that 10% of variability is relatively common when we make a soil analysis. Other labs could have different standards, but yeah, usually below 10%, it's not. It doesn't worth the effort to try to understand where the variation comes from. And so we also made a comparison of our result with the GLOSOLAN methods here with the Ukrainian results. And as you can see, there is a good correlation. They are not far from a regression line. So we have a good R square here, but there is a bias between the two methods. So the slope is less than 1 here. So it means that there are differences between both methods, and these differences are increasing with the absolute value. But you could transform, as you have very good square, R square, you could transform one method to another one. We also compared the Olsen from the FAO-GSP with, as we made EDTA extraction for another parameters, we just measured what we could measure in this extractor, and we measured the phosphorus. So both are made in our lab with different methods, and gives you an indication of the differences here linked to the extraction solution. The R square is significant, but is a bit less. And regarding the differences, we see that we see that the Olsen is mobilizing more than EDTA at small value, and is maybe mobilizing less at a high value. But yeah, as we only have 1 point and 2 points here, we should take care with this kind of lights. But yeah, it means that correlation are a bit less good, mostly probably because of the extraction, the composition of the extraction solution here. So I don't know if we made a stop before going to potassium, or Maybe, if you have questions.
Yeah. Thank you, Gilles, for again showing how phosphor is measured, or the mobile fraction thereof. Coming back again to the comparisons that you made, the last one with the DKI you were mentioning, you are trying to have a method where you can use one single extraction and then try to measure the nutrients in order to have it more efficient. Is that the idea?
Yeah, it's because it's because we work in a network with a laboratory that make soil analysis for farmers. And a long time ago, the head of this unit was made his thesis on phosphorus. So he was he knew a lot about the methods and so on. And at that time they were doing another method, which is, I think it was acetate lactate. But the laboratory, they had cottony for calcium, magnesium, potassium, and they were wondering if they could simplify their scheme by making one single extract for all the parameters. And so that's, after tests they made, they choose to apply these methods to phosphorus too.
Okay, no.
And also for the micronutrients and so on.
Yeah. Okay. Then maybe a more general question. What is the status of phosphorus, let's say, in topsoils in general in Europe? Would you say they are more like elevating or more going down, or or maybe also in Belgium, what the situation is, depending on?
Yeah, the situation in Belgium is in southern Belgium is the farmers try to limit the use of fertilizers because it might be expensive. And so we see on the long-term fertilization, when you have the modalities, which is what is the standard application. Another parcel will have a double application, and one will have zero application of phosphorus. And if you look at that, we see that it took very long time for the crops to answer to zero P. We see with the time that the phosphorus in the soils decrease when you don't apply phosphorus, but most crops don't really mind with that. It's not a problem because the levels at the beginning were relatively high. So we can afford not to put too many phosphorus, and it seems that in some of in the Leuze belt and so on, in the northern part of southern Belgium, the trend is to decrease the phosphorus levels. Yeah. At the other part, there is no significant evolution. Yeah. Phosphorus might be a problem linked to surface water eutrophication, as it is often the limiting factor for the algal development. With the erosion, the phosphorus is input in the water streams, and the algal can develop with that. Yeah, but in southern Belgium, it's less a problem because there is less erosion and the soils are less rich in phosphorus.
Okay, thank you for this question, for answering this question. I don't have any other question at this moment. So,
okay.
Go on with the mobile.
Let's go to potassium. It will relatively faster because things has already been said for some of the parts. There's less new novelty to introduce. What we want to measure with the mobile potassium is that again the plant needs to uptake from the soil solution. So the dissolved potassium is important to know, but also this solution is interacting with the mineral phase, and it's mostly the clay content, which will, on the cationic exchange capacity, you will find some negative charge that can absorb the potassium. And in the clay, you could have processes of potassium trapping. The clays are open, and when some of the clays, such as the highlights, elite, I don't know exactly pronunciation in English, they are open, and when potassium is put in their system, they just close, and so they block the potassium. So when we want to assess the quantity of potassium that is in the soil, we will try to have extractant that take the dissolved and the easily exchangeable potassium. What changes in the principle is that mostly at the end here, you will work with the flame absorption or flame emission, flame spectroscopy. So you don't need to change the color, you just need to have extract. The principles that you send light within the with given wavelength within the flame, and it is absorbed. And then again, you have a standard. You make a calibration lines, and you can transform the absorbance into concentration. So this is absorption. You also have emission, is that you don't have a light that is passing through, but it's the potassium which is burning, which is emitting the light that you measure. So here you have methods from the Ukraine, which is the same as the phosphorus. So it's ammonium carbonate solution that takes the potassium. In our standards, we use like an Enervio, and so it's a mixture of ammonium acetate and EDTA at pH 4.65. EDTA is a chelating agent that can interact with the specific elements in the soil solution, and prevent to interact with the other elements, for example. So we try to use it as a universal extractant of major cation, also anions such as phosphate, and minor nutrients, as I already said. Regarding the reagents, so we have ammonium acetate, we have EDTA, we have acetic acid, and we also have titrisol solution. So that's a standardized concentration of the elements that we are interested in, and that allow us to make the standards. Regarding the procedure, we have 1:5 ratio of soil to extraction solution. So we weigh 10 grams of 2 millimeter soils in the centrifuge tube. We had 50 milliliters of the extraction solution. We shake 30 minutes, and we filtrate and discard the first milliliters. So This is the adding of the solution. This is the agitation and the filtration. Then we prepare the standards for the calibration curve, and we measure. In this case, it has been measured with the ICP-OES and not with the flame atomic emission. So this is a photo of ICP-OES, but it's found on the web and it's not someone from our team. And the idea is that with the ICP-OES, the advantage is that you can be in multi-element mode. So you just you specify every element that you need to measure, the wavelengths, the standards, and so on, and it sucks the solution and do all the measurements at once. While in the flame emission or flame absorption, you need to make the elements one by one. But the apparatus have their own specification, and sometimes they are more precise in flame absorption than in ICP-OES. So depends on the elements. So main principle of calculation is the other one. The lecture minus Blanco multiplied by the volume, the dilution factor, the moisture factor, and divided by the mass. We made a comparison between Ukrainian results and our method, and you see that they are almost identical. Only here we have 2 points that are a bit far away, but if you look at the results, they are following the 1-1 straight line, and I think it looks like the extraction of potassium is not sensitive to the kind of counter ions that you put into the solution between these two methods. Okay, maybe I will go to mobile sulfur in order to finish, and we make questions, answer questions after.
Great, that's fine.
Okay, so mobile sulfur is similar to nitrogen in the principle. So it's again colorimetry that could be used, but in the standards of Ukraine, when you put your you add, so you have a sulfate in solution, you add elements in order to precipitate the sulfate, and that's something that we did not make. We changed the method by using ICP to measure directly the sulfur in the soil solution. So we did. In the procedure, usually you should make an extraction with the potassium chloride solution, so such as we do for the nitrogen. And then you precipitate the sulfate with barium chloride. So sulfate barium is a very low, has a low dissolution potential, so it precipitates rapidly. And you measure the sulfur by the optical density using a spectrophotometer or photoelectric colorimeter. And you should add soluble starch, the suspension stabilizer, during the test. So that's the method of of Ukraine, and we thought it was more simple to take the same extractant and to directly measure it in the solution. So regarding the preparation of the sample, again, the sample here are supposed to be dried, well-ventilated room, not exposed to sunlight, to remove stones and so on. So it's very classical. And the preparation of the solution is KCl, 1 molar KCl, and the pH between 5.6 to 6. So there are instructions to prepare the extract, and you add the potassium chloride. You make a blank test. It's important, of course. You shake during 1 minute. You settle for after the reaction to be made for 80 to 20 hours, and then you shake again and you filter. So that was made by our technician. These are the different steps, except that for the measurement, we use the ICP OES. And what we found is that the results are here. It's the 1-1. If we make a straight line, a regression line in our results, we see that it's almost a horizontal line. So there is no really a trend. But we also see that we have here a point that is a bit strange, and we guess it's an analytical error, and we should do it again in order to verify this point. Otherwise, we can say that we have the same range of magnitude, but we measure more at the lowest value. We measure 2 times or 3 times more sulfur by ICP than by the other one. So it might be a problem to compare sulfate. So yeah, we'll just hear in introduction. A conclusion is an introduction to what will be seen later. But at this stage, if you want to have a look at the results globally, you can make here a PCA analysis in order to see where are the correlations between the elements, and see that if you look at that, we have a kind of gradient regarding these elements, and we added the pH and the TOC that were measured by Vito. If we look at these elements, see that the 40 samples are located on the gradient with the, here we will find the richest soil samples, and here the poorest soil samples, because they are all the variable at this moment are pushing the samples on one direction. And if you look at the second one, you will find here within the elements, the one that have the highest P and K content, and here the one that have the highest pH. But yeah, we will see later this afternoon when we will have all the samples, all the parameters analyzed. So that was the last slide of this morning, and I'm open to your questions.
Okay, thank you, Jim. Maybe one question related to the determination of the sulfate and maybe as well phosphate. At some point, I understand for the sulfate you mentioned they were measured by ICP.
Yeah.
Yeah. And it's just a question or also a remark. When you measure like sulfate or phosphate with ICP versus colorimetry,
Yeah.
the idea is, of course, with ICP, you measure the total S, let's say, and maybe also the total P.
Yeah.
Is there any possibility that, for example, sorry, is there any, sorry, my headphone was wrong, sorry. Is there, so I repeat my question. If you compare the measurement with ICP and colorimetry, the ICP measures total P and total S, while the colorimetry measures sulfate and phosphate. Is there any selectivity in the extraction that, for example, also maybe organic sulfate or organic phosphates would be present and can influence this result? Or on the one hand, I saw at some point you also added some charcoal maybe to remove some organic. Could you maybe comment or discuss this as well?
Yeah, you're right. It's a point. I'm not a specialist in sulfate, so I don't know.
Yeah.
We know that the most of the sulfur in the soil is under organic form, but it must be transformed into sulfate to go into into the plant, so in the soil solution. Uh, yeah, maybe there are some dissolved or yeah, colloidal form of sulfate or phosphorus that could be, yeah, that could explain the fact that we measure more. Yeah, sure.
Yeah. Yeah.
Must be
No, okay.
investigated. Maybe, yeah, we should do more test on that. Yeah.
Yeah. No, I know. I mean, from the past, this has also been a discussion because some people like to use the ICP OES, of course,
Yeah.
because it can have some advantages. But indeed, you measure the total S,
Differences. Yeah.
total P. So it depends if you only can know that phosphate and sulfate are present in that form,
Mhm.
then it's comparable with the colorimetry because they only measure the oxyanions,
Mhm.
while in the other case, but okay, this is indeed something to be studied further, maybe.
Yeah, yeah, sure.
I'm looking if there are any other questions. No, I don't see any question pumping up, Gilles, at the moment. I understood from you also that this mobile sulfate is not often requested as an analysis. Is this maybe, I would not say less important, but maybe something that's overlooked maybe and that we should consider?
Yeah, we really we never measure sulfur in soil,
Hmm.
but recently the lab asked to add sulfur in the proficiency test because they think that there is a trend. Uh, it is supposed that with the cleaning of the emissions from the industrial activities, there is less sulfur that goes to the soil. And so still the same quantity, also less sulfur that is applied through fertilization. So you have less input to the soils and you have the same amounts of exportation with the crops. And so there should be a decline in the sulfur content of the soils and might be appropriate to add some more. And so we have to know the status of the sulfur. So this is a recent trend, but I found the book and was reading this introduction of the book this morning. It's about a report that was made in 1991, so it's a long time ago, and they were saying exactly the same. It was about nitrogen and sulfur in soil, and they were saying exactly the same as that the sulfur was declining and so on and so on. So I think it depends on the yeah. It's not a new process, but we miss references. maybe it's a kind of initiative from the fertilizer company who wants to sell sulfur. I don't know exactly, but yeah, it has been it has not been very well studied in our region.
Okay, so it might be that it's a new interesting parameter because indeed the NPK that you mentioned, they are added as a fertilizer, for instance.
Yeah.
But sulfur, basically, it's not at this moment added except from atmospheric deposition, let's say, or natural processes, but not as really a fertilizer inside, if I'm correct. And that's maybe now the
It used to
question.
be, but it's less.
Okay.
Yes.
Okay. No,
But
that's clear.
I think I've been asked because they are in France they are making recommendations and they want to expand it about using gypsum on soils, spreading
Okay.
gypsum on soils to correct the potential sulfur deficiencies.
Okay.
But
No, thank
we
you.
should be sure that it's really limiting factor before.
Yeah.
Don't know
Okay.
exactly. I don't have enough references to
No.
say it.
And then we got a question from the audience asking ICP method measures elemental P, then converts it to P2O5 by molecular weight. Is this correct?
Yeah, we measure P, yeah, and then after we convert it into P2O5, yeah.
Yeah.
It's because it's usually the way to express it. I prefer working in what you measure, so in element. But yeah, as people in the methods, I think it's expressed in the P2O5. So we just made a multiplication.
Yeah, so that's indeed correct with the ICP method. The ICP is like a plasma, and then basically all the forms of P, be it organic P or phosphate or any else, is converted indeed to like the atomic P.
Mm-hmm.
And then you measure indeed the total P, let's put it that way, with the ICP.
Yeah.
And then, as you said, you just convert it by calculation of the molecule mass to P2O5.
Mm-hmm.
So that's
Yeah.
indeed correct.
Mm.
Another question we received, Gilles,
Yeah.
what are the main forms of phosphorus in the soil? And I think you had a nice graph to complement that, I guess.
Dim, 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 dim. This one. That one.
Yeah.
Yeah. Of course, it depends on the context, but in our region, it's the most important is inorganic phosphorus, because there is in the Leus there was some phosphorus, and of course they used to fertilize too and so on. So we have a good mineral reserve. I think 70% of phosphorus is under inorganic form, and the rest organic phosphorus. If you go into the southern part of Belgium, there is more organic matter. The proportion might change. Probably in Ukraine, where in Chernozems and so on, the organic phosphorus should be very high too. We did not make the fractionation scheme on that. It might be interesting to see. And yeah, after for the mineral interactions, if you have carbonates in the soils, the phosphorus will precipitate with the carbonates. In highly weathered soils in Africa, the phosphorus precipitates with the iron oxides a lot. So yeah, it really depends on the context that you are going to study.
Okay, I think that answers the question, hopefully. I don't see any more
Phosphorus is
questions.
very friendly. He likes to bind to anyone.
Okay, that's maybe a good thing to remember. Yeah. No. Okay. Thank you once again, Gilles, for giving this overview of these nutrients and the mobile forms thereof and how to determine them. We are a little bit in advance of schedule, but that's okay. The next session will now start at 2 o'clock. So this is 3 o'clock your time. So we have now a break, I think, of more or less 3 hours before we continue. And then this will be with some other analytical and lab techniques that Jill will present. So if that's fine, I would like to conclude the session here. And then we see each other within more or less 3 hours. Thank you.